Okay, welcome everyone. In this video, we want to continue working with functions. And so we're working with this same Colab notebook on functions, which is linked in the description of this video. And the functions that we're going to work with here are a little more advanced. So they're going to be related to statistical distributions. And so if you're curious about reading more about the theory behind statistical distributions, and about the R functions that we can use to work with them and going through more examples. I'm just going to do one example in this video. There are some links provided over here in this section. You can click on those and go through those materials. It's certainly not required, but if you're curious about it, feel free to go through. When I say common distributions, there are discrete distributions. These are distributions that we use for random variables that are used like to count things, like how many successes are there when we repeat the same trial under the same conditions over and over again, like a binomial distribution. And there are other continuous random variables, and these are things that we use to like measure things. And I would say out of those, by far the most common distribution that we would want to work with would be the normal distribution, since that's what comes up when we're doing things like sampling distributions in the central limit theorem. But in any case, if you want a deeper understanding, a deeper background on statistical distributions, feel free to look through those materials. It's not going to be a huge emphasis on the homework, so you don't need to get too stressed out about it. I just want to direct you to some materials if you are curious about it, and just give you like a little background and introduction to it in this video if you're curious about it. But there are really like four main functions that you would want to work with for each distribution, common distribution in R. So there would be like a P distribution function, a Q distribution function, a D distribution function, and an R distribution function. And I think really this might seem like really confusing. I think like the best way to kind of explain how these functions work is to do an example with, say, like a normal distribution, which is what will come next. But to kind of explain how this works, so maybe let me just work with an example to kind of explain how this works. So let's take the following example. We'll work with a normal distribution. So let's let X be the birth weight in grams of a randomly selected full-term baby. And based on some data, let's suppose that it's a fairly good approximation that X is approximately normally distributed with a mean of 3,500 grams and a standard deviation of 600 grams. And down below, I'm going to just create a plot that's going to tie in with the question in the first part, question 1A. And this plot that I'm creating, this is not the focus of this question. I'm using a package called ggplot2, which is just a little preview of what's coming next week. We're going to work with this package for the next couple of weeks to create more advanced visualizations. But here is a plot of this normal distribution, which has a mean of 3,500, and we've got a standard deviation of 600. So that's what we were told about this distribution. And so question 1A is asking us, let's find the probability that a randomly selected newborn is less than or equal to 4,200 grams. So yeah, 4,200. And I have that, I want to mark that on my plot. So that's right over here. So visually, what I would like to do, this probability right, corresponds to this area that's marked in blue. So I would like to calculate this area marked in blue. And so there are different ways to do this. For those that have taken a probability or a statistics class that didn't use R, you might have used a graphing calculator, or you might have used like a table. You might have found z-scores and then used like a standardized normal distribution table to calculate these probabilities. But I want to talk about how we can use R to calculate these probabilities using these built-in distribution functions in R. And so there are these four functions that we could think about. And so here, our distribution is the norm distribution. And there are a couple of functions to think about here. So this is what I was kind of talking about up here when I said there's p dist, q dist, d dist, and r dist. Dist would correspond to the distribution that you're working with. So in this case, our random variable is following a normal distribution. So I'm using norm for the distribution. If it was a binomial distribution, then instead of using norm over here, then you would use binom and binom, etc. So if you have a different distribution, then you just change the distribution name to whatever the corresponding distribution might be. If you have a geometric distribution, then you would use geom and so on. But for us, we are going to stick with working with the normal distribution in this case. So these are our options. This p-norm function is going to calculate the area to the left of x. So in other words, this is going to be the probability x is less than or equal to x. And that's exactly what we want here. So this is calculating this area in blue. That's exactly what we want to answer part A. This d-norm function, this is calculating the height, or let me say it like this, the value of the PDF function at x equals, in this case, if we were to do 4,200. So this is telling me if I were to plug in 4,200, it's going to come up, tell me the height of this function, and it's going to come across and tell me what the probability density is. So it's telling me like the height, it's going to tell me what the y value is of this point on this graph. So for continuous distributions, continuous random variables, that's not really useful when we're trying to find probabilities. It's almost never useful. So for continuous distributions, we calculate probabilities by calculating areas underneath the curves. So we're almost always going to be wanting to use the p-dist function to calculate probability. So that's what the p really stands for, is probability. The d really stands for density. And that is really not useful when we're working with continuous distributions. It might be useful when you're working with a discrete random variable, because it might, when you're in the case when you're trying to calculate what's the probability that you would get exactly 5 successes out of 20 attempts, that might be useful when you're working with a discrete random variable. But for our situation here, we have a continuous random variable. Finding the height on the probability density function, that's not going to really tell us anything about the probability uh, finding that a randomly selected child is going to be have a weight that's less than or equal to 4,200 grams. So this d norm function, that's not going to be useful. The q norm function, this is a quantile function, and this is kind of like the inverse of the CDF function. And so this is what we use to find percentiles. So if, for example, I said, hey, what is the 95th percentile for birth weight? Then that's going to be useful function for that. So in this case, I'm given a weight and it's asking me to calculate a probability. So the p norm is going to be useful for that. There might be some situations where I'm given a probability and I'm asked to find what is the corresponding weight for which that corresponds to that probability, and that's where the q norm function is going to come in handy for that. And we'll see a question like that in a moment. And the R norm function, this is what we use to generate random samples. And that's not what we're asked to do here. So these are these four functions. The p norm function is used to calculate probabilities. You could really think about this as calculating areas underneath of the PDF. The d norm function is used to calculate densities, probability densities. This is what you can think of as calculating like the height on the PDF function, which is really not useful for continuous random variables most of the time. The q norm function, that's going to be useful for calculating percentiles. The R norm function, that's going to be useful for generating random samples. And this P, D, Q, R, that first letter, that pretty much applies to any other distribution. So that convention applies whether I have a normal distribution, an exponential distribution, a binomial distribution, and so on. So the P before the distribution calculates areas beneath the curve. The D before the distribution, that calculates the density. The Q before the distribution, that calculates the quantile. The R before the distribution, that's going to generate random samples. Okay, so that was a general introduction about these distribution functions. I will take a break now, and then we're going to just come back and answer this question 1A in a separate video, since I think I talked enough about these functions in general in this video. Thanks, everyone.